With SPSS, we can calculate the skewness value, or how skewed the scores or values are of a variable. If the skewness value is a positive 2 or greater, we can say that we have a positively skewed distribution. If the skewness value is minus 2 or more, we would determine that we have a negatively skewed distribution. We can visually assess skewness as well as support our assessment with skewness values. The skewness values come in handy when close to subtle changes occur, and it is difficult to make a definitive visual declaration of skewness. Another function of a distribution is to ascertain what proportion of cases or participants in a normal distribution fall in any specified number of standard deviations above or below the mean. A standard deviation is a measure of variation for interval ratio variables. It is equal to the square root of the variance. Remember, as I stated in the previous PowerPoint, it is important for you to know the variance as well as how to calculate it. The standard deviation is the square root of the sum of the squared deviations from the mean divided by the total number of cases or participants minus 1. Now, if you don't have SPSS handy and you have memorized this formula, you can calculate the standard deviation or deviation from the mean by hand. If you are feeling a little overwhelmed right now, don't worry. Keep reviewing the formulas and it will become easier for you. Here's a review of the formula for calculating variance. Here, we have a normal distribution and the percentages related to each standard deviation. If we go one standard deviation to the right of the mean, 34.13% of the scores fall between the mean and one standard deviation. If we go one standard deviation to the left, scores between the mean and one standard deviation to the left of the mean encompass the same percentage, 34.13. If we wanted to know the percentage of student scores between one standard deviation below the mean and one standard deviation above, we would add 34.13 and 34.13, which would equal 68.26. If we wanted to know the percentages of scores between the mean and two standard deviations to the right, we would find that one standard deviation from the mean equals 34.13, and the percentage between one standard deviation and two standard deviations is 13.6%. If we add 34.13 and 13.6, we obtain 47.73. Therefore, if we want to know the percentages of scores between two standard deviations below the mean to two standard deviations above the mean, we would add 47.73% and 47.73%, which equals 95.46% of the total scores. If we wanted to know the percentage of scores between the mean and three standard deviations above the mean, we would add 34.13, 13.6, and 2.13 to obtain 49.86%. If we wanted to know the percentages of scores from three standard deviations below the mean to three standard deviations above the mean, we know that a normal curve is symmetrical, and each side from the mean to three standard deviations represents 49.86%. Therefore, we would add 49.86% plus 49.86% to obtain 99.72%. We would state that 99.72% of the scores lie between three standard deviations below and above the mean. To determine the percentages of scores lying between two standard deviations and three standard deviations above or below the mean, we subtract 47.73% from 49.86%, which is the percentage of scores for two standard deviations from 99.72 divided by 2 equals 49.86% minus 47.73, which equals 2.13%. Notice that the standard deviation value decreases as the number of standard deviations increases. This happens as the frequencies of the scores decrease as we reach farther out to the end of the curve, or what we call the tails. If this is confusing, please reread your text and then review this PowerPoint. It might take a couple of reviews to understand standard deviations and their related percentages. Be sure to conquer these concepts, as all subsequent lessons rely on prior lessons. Previously, I mentioned another type of distribution called kurtosis. This distribution refers to the degree of how peaked or flat the distribution appears. The degree that the curve is peaked or flat depends on the frequency of the values of the mean or the size of the mean. A large standard deviation indicates that the scores are widely spread, or sometimes we have a small number of cases. This results in a flatter presentation of the curve as the scores spread out. A small standard deviation indicates that the scores are closer together, which results in a peaked formation of the curve. There are three types of kurtosis which you should know. The first is platykurtic, where the scores are scattered farther from the mean, hence the curve is flatter. SPSS will provide us with a kurtosis value. If the value is less than -1, a platykurtic curve exists. With a leptokurtic curve, the scores are closer to the mean, with the curve appearing peaked. The SPSS statistic that is obtained for leptokurtic curves would be greater than +1. A normal curve is neither peaked nor flat. We refer to this as a mesokurtic distribution. The kurtosis statistic provided by SPSS would range between greater than -1 and less than +1. Once we start conducting formulas using SPSS, we'll check for kurtosis and skewness values. Remember, a mode is the most frequent value that occurs in a sample of scores for a variable. However, sometimes we may have two modes. Think of a camel with two humps. While the values may not be exactly the same as depicted in the curve shown, it is important to recognize the presence of two modes. So if our students' scores showed two modes with scores for each mode being 80 and 90, we would know that the students most frequently obtain the scores of 80 and 90. I hope you found this PowerPoint useful in understanding the concept of distribution. If you have any questions, please reread your textbook. If you continue to have questions, please post your question on Ask the Professor.